So the two big things that we need to be able to do, are to go back and forth between a graph of a linear equation and the equation in algebra form for that equation. So that's two skills. We need to be able to take an equation for a line and be able to produce a graph, right? So be able to actually sketch out a graph that accurately depicts that relationship described by this equation between the variables x and y. And then the other way, to be able to look at a graph of a linear equation and produce an equation that models that relationship. So we need to be able to go both directions. And the touchstone, the universal skill in this whole unit is kind of the skill at the intermediate level. So I don't want to talk about this one first. Intermediate. But the intermediate level skill is to be able to write an equation for a line that joins 2 points. This is going to be a skill that you use a lot, not only in our course, but especially moving forward into pre-calculus and into calculus. This is a very common skill that's going to keep coming back to you. So if you take nothing else away from this unit, make sure that you come away knowing how, given 2 points, that you know how to determine an equation for the line that connects those 2 points. So we'll talk about that intermediate level skill in a moment. But first, let's start at the ground floor. At the beginner level, we were introduced to the concept of what slope is and what slope means. So at the beginner level, I would say that our skill here is to find the slope of a line and use it. Or maybe, let's not say use it, let's say find the slope of a line and relate it to the direction of a graph. And as is always the case in these circles of ideas, in order to do the intermediate level task, we're going to need to know how to do the beginner task. Right? We're not going to know how to find an equation for a line that connects 2 points unless we first know how to find the slope of the line that joins those 2 points. So we need to figure out how to do the beginner part before we worry about the intermediate part. So let's start with this example that's up here. I've labeled 2 points, and I'm going to indicate real quickly what the scale on this graph paper is here. So this is going by ones in both the horizontal and vertical direction. Okay. So give me, what are the coordinates of this point over here on the right? So the coordinates of the point over here on the right are 5, -2. And using that same method for counting to find the coordinates, what are the coordinates of my first point over here? So we have the coordinates of our 2 points, -3, 5, the point on the left, 5, -2, the point on the right. And at the beginner level, the question is, how do I find the slope of this line which goes through these 2 points? It has these 2 coordinates. If I know what the points are, how do I find the slope? On the one hand, if we happen to know the slope of a line, we can use that slope to help build an equation, and that's what we're going to do at the intermediate level here, right? The slope is going to be this parameter in the equation that we call m. Right, so the first step is we have to find m. To find m, we go back to the definition, which says that the slope is a ratio. It's a ratio of what we sometimes call the rise of the graph to what we sometimes call the run of the graph. Rise over run, that's how people often remember this. So what does rise mean? So when we say rise, we mean the difference between the y-coordinate of the first point and the y-coordinate of the second point. So we can write that on my graph over here. This is the difference that we like to call the rise. And to find it, it's really more of a fall than it is a rise when I look at it this way. But to find it, we just have to subtract the second y-coordinate from the first y-coordinate. So y2 minus y1. So let's take just a moment and do that step for these 2 points. For these 2 points, what are my y2 and y1? Yeah, -2 is my y2, and 5 is my y1, right? So I'm looking at both of the y coordinates of my points, and I'm just going to subtract one from the other. The good news is it doesn't matter which one we put in which place, as long as we get both of the y coordinates in my subtraction. And as long as we're consistent, that if I'm saying that -2 is my second y coordinate, then I'm going to need to say that its partner, 5, is my second x coordinate. Right? So when we go to do the run, we have to subtract the run in the same order that we subtracted the rise. So we'll have -2 minus 5, and what is -2 minus 5? -7. So again, a place that potentially has a lurking sign error. Don't forget, we're adding here 2 numbers with the same sign. They're both negative. And so we end up with adding their absolute values and having the answer be negative. And so the rise, or the vertical difference between these 2 points, is -7, which we can interpret as just, in order to get from here to there, we just have to count down by 7. 1, 2, 3, 4, 5, 6, 7. So that describes the rise, the vertical difference between those 2 points. Where do we get the run from? Yeah, from the x-coordinates instead of from the y's, right? We play the same game where we want to know how much horizontal distance separates these 2 points. And so we'll do the same operation, subtraction, but this time using the x-coordinates, x2 minus x1. So if y2, in this example, was -2, then what's x2? 5, right? It's the y2's partner. Okay. So the 2 coordinates of the point 5, -2, when we write them in the slope formula, they should be right above one another. Okay. So we're sure that we're subtracting in the consistent order. So 5, the x-coordinate of the second point, minus -3. And what is 5 minus -3? Positive 8, right. It's the same thing as 5 plus +3. And that +8, again, we can envision as that which I have to do to get from this point to that point horizontally. How many spaces do we count? 1, 2, 3, 4, 5, 6, 7, 8. So we have the rise, we have the run, we divide the 2 of them, and that tells me the slope of this line. And we relate it to the direction of the graph by observing that we have this triangle that joins these 2 points, and the ratio of the lengths of the sides of this triangle are in the ratio of 7 to 8. What does it mean, though, that this slope is negative? How does that show up as part of my graph? Yeah, right. The fact this is a negative slope is reflected in the fact that my line is decreasing as we go from left to right. Right. As I go from left to right along this line, my y-coordinates are falling. They're decreasing. So negative slope gives us a decreasing line. Positive slope would give us a line that goes upward as we go from left to right. Okay, great. So we're part of the way already to our intermediate level skill. At our intermediate level, we not only want to know what is the slope of this line, but we want to know entirely, give me an equation in algebra that relates together the x-coordinate and the y-coordinate of every point on this line. Every point on the red line has to be related. Its x and y coordinates have to be related by the same equation. And how do we find such an equation? Now, you told me a minute ago that there is a template, and the template is what we call the slope-intercept equation, y equals mx plus b, that we can always use as a starting point to give us a pattern for this equation that we're going to find for this graph. And in that equation, m is the parameter that represents the slope. So if we find the slope, we can just stuff it right in to where we have an m, and we're halfway there. All we need to know now is what to put in this other parameter that we call b. So first of all, what does b actually represent in the slope-intercept equation? Yeah, it represents the y-intercept, specifically the y-coordinate of the y-intercept for our line. And knowing that at least gives us a consistency check. Looking at this graph, what would we expect b to be, approximately. So the by y-intercept, we mean where does the y-axis intersect my line? So I just look for where my line crosses the y-axis, and that's this point right about here. And so we would expect that b in my equation is some number between 2 and 3. Right. So when we go forward and we actually find the value for this, that's our consistency check. If we get something that's not even close to a number between 2 and 3, then probably we did something that we're about to do incorrectly. Right? Make sure you catch those mistakes, because it's better that you catch them than that I catch them. So we know b is something between 2 and 3, but that's not enough for us. We want to know exactly what the value of b is for this line. So we have to do a little bit more work. What should I do? What is the nature of the rest of that work that's going to help me to find b? So we need to solve this equation to determine the value for b. So we need to get b by itself. The issue is this equation also has an x and a y in it. So I'm not going to get a number if I just solve this thing for b. We could implement something we talked about on Wednesday of last week and just get the b by itself here first. How would I get the b by itself in this equation without resorting to numbers?
You would add 7/8 x.
I could get the b by itself by adding 7/8 x onto both sides, so that at least what I would end up with is an equation that says something like b equals y plus 7/8 x. And that's true. The issue is that we need b to be a number, so that I can actually put a number into my equation and be done. And b is not going to be a number unless x and y are somehow also numbers. So we need numbers that we can put in for x and y. Where can I get numbers to plug in for x and y that we know must satisfy this equation and therefore be a point on this line? We can get an x and a y just by using any of the points that we know must be on this graph. And the problem came to us in a fashion where we already know what 2 points on this line are. So we can use either one that we want to, as long as we pull the x and the y from the same point. So let's say I use this point. If I replace x by 5 and y by -2 in this equation, then all I should have to do is evaluate this right-hand side, and it's going to spit out my b. So let's do that. In place of my y, I'm going to put empty set of parentheses. In place of my x, empty set of parentheses. And the x that we would choose from this coordinate here is 5. And the y, -2. And so now all we have to do is do -2 plus 7/8 times 5. So we dust off our fraction hats. How do I do 7/8 times 5 over 1? Straight across. So 35 over 8. Now I'm going to skip down to the bottom here. What's a good common denominator to use for these two fractions? 8. And the second fraction's already in that denominator, so that's nice. How do I bring -2 as a numerator into having a denominator of 8? Multiply by 8. And so that's going to give me -16 here. And then to add these two fractions, add straight across the numerators. 35 minus 16 is going to give me 19. And so the value of b is 19 over 8. If I divide 19 by 8, or if we reduce it into a mixed number, I'm going to get 2 and 3/8. What do we think about 2 and 3/8 for the y-intercept? Does it seem reasonable? Yeah, it's somewhere between 2 and 3. It's a little bit closer to 2 than it is to 3, because 3/8 is a little bit less than a half. So that certainly comports with the picture that we have, which is good. That's our consistency check. If we got something crazy like -21 over 6 or something, then we should doubt our work. Or we should at least doubt that our work is reflective of the line that was given to us in the problem. But 19 over 8 seems to fit the picture perfectly. And so our last step is just to put that number into my equation. 19 over 8. And then this would then be our final answer for a problem that asks us to find an equation for the line that joins these 2 points. So there was a lot of work. There's a multi-step process. We had to first figure out what is the slope of the line that joins those 2 points. That was where we did the rise over run work up here at the top. We found the slope was -7/8. And then knowing that the slope was -7/8, we plugged that into the m of our y equals mx plus b template. Right? That template is a multi-tool. Hang on to it. It's really super useful. Plugging that negative 7/8 into that template then gives us an equation we can rearrange and solve for b, but in order to do so, we have to supply that equation with an x and a y, drawn from our original points. We chose the original point 5, -2. It gave us this value for b. But what's really cool about this is we could have chosen the other point, -3, 5, and it should have given us the same answer. Right? We could check it if we wanted to. Let's see. So this was y, that would be 5, plus 7/8 times -3. 5 plus 7/8 times -3 is going to be 5 plus -21/8. It's going to be 40/8 plus -21/8. 40 minus 21 is 19, and we have 19/8. Cool. That's, by the way, another way for us to know that we got the slope right. Because if this would have given us a different value for b for our two different points that we know are on the line, that meant that our slope was wrong. So as long as your slope is correct, it doesn't matter which of these 2 points you pick. If your slope is incorrect, then the 2 different points you pick are going to give you different answers for the y-intercept. So if you have extra time on the exam and you doubt your slope, one way of checking your slope is by plugging both points in to the y equals mx plus b and verifying whether they give you the same b or not. If your slope is right, they should give you the same b. Also, it bears mention, don't forget this very last step. After you find b and did all the hard work, don't rest just yet. Plug that back into your original equation and then put a big box around it. Because your final answer needs to be an equation, not just a value of m and a value of b. It needs to be y equals your m times x plus your b. At this point, we have now a variety of tools to figure out what an equation for a given line is. And so the advanced level, our last step up the mountain, the expert level skill, is we want to use slope in yet another way. And what we want to do with it this time is to use the slope to determine a geometric relationship between two lines. Specifically, use the slope to determine whether two lines are parallel or perpendicular. And those are two different questions, so we're going to have to look at each one of them separately. Parallel or perpendicular. So there's our advanced level skill for this. First of all, let me ask the question about parallel. What does it mean for two lines to be parallel? How can you tell visually if I'm looking at a set of parallel lines? The mental picture of two parallel lines is that they're two lines that don't have any intersection point, which is true in Euclidean geometry, but may not be true in non-Euclidean geometry. I'm just going to leave that out there for the math majors in the audience. And they tend to be, in our mental picture of them, they tend to be these two lines that are kind of next to each other, but they are not ever going to cross one another. They don't have any point in common. So here would be an example in the red here of two lines that are parallel. So here's my question. What is it about the slopes of these two lines that makes them parallel? We know the slope of our original line here was -7/8. We did all the arithmetic and everything on that. What would you expect the slope of this other red line to be?
Same.
Why? Greg?
Why?
We expect that the slopes of these two lines are going to be exactly the same because however much one of them rises compared to its run, the other one will also have to rise that same amount in relation to its run. Another way to say that would just be that if I take the 2 points on my other line, which are kind of in the same place as the 2 points that we started with on our line, then we should be able to draw in that very same rise and run triangle for my second line as we had for our first line. Right? And if that's true, then this amount of rise here should also be -7, and this amount of run should also be +8. And if the rise is -7 and the run is +8, then the slope is -7/8. So that's the good news. Parallel is simple. We don't have to do anything with the slope. Parallel means that the slopes are equal. Now keep in mind here, we're talking about a relationship between two lines when we say parallel or when we say perpendicular. And so the typical kind of problem in this arena starts with one line that we want to know something about, right? So in our example, it started with this line that we've been analyzing here, right? This line that goes through the 2 points that we were given. We figured out what its slope was. We figured out an equation for it, right? And then the question will ask us something like, what would the slope of this other line be, which is parallel to the original? And so knowing that it's parallel, we would know that the slope is equal to the original. And since we know the slope of the original, we can say that the slope of this parallel line is negative 7/8. Okay. So first of all, if we're going perpendicular instead of parallel, what does perpendicular mean? What's your mental picture for what two perpendicular lines look like? So the essence of two lines being perpendicular is that they do cross, and where they cross, they make a 90-degree angle with one another, right? Or what you call a right angle. So maybe this line sketched in here, the blue line here, would be perpendicular to the red line because the angle that they make when they meet is a 90-degree angle. Okay. For example, the x-axis and the y-axis are two lines that are perpendicular to one another, right? They come together at a 90-degree angle. It's also true, the first thing you said is also true, that perpendicular lines go in different directions in the sense that if one of them is decreasing, the other one had better be increasing on this graph, right? It's not possible for us to have two lines that meet at a 90-degree angle and have them both be increasing or both be decreasing. So already we know something, according to that, about the slopes of two perpendicular lines. What is it? Just based on the observation that one of them has to be increasing, the other one has to be decreasing, what can we say about their slopes? What do we know about the slope of an increasing line? What kind of a number should it be? It better be positive. And the slope of a decreasing line? Better be negative. So, because two perpendicular lines have to be one increasing, one decreasing, that means that their slopes had better be opposite. One positive, one negative. So that's the first clue on how to relate the slopes of perpendicular lines. So let's imagine for a moment that this is my original line. And this original line is going to have a slope of negative 1/4. And I'll illustrate on the diagram why it has a slope of negative 1/4. It has a rise, if you will, of, I'll put the figure over here. It has a rise of negative 1 combined with a run of positive 4. And so this line here has a slope of negative 1/4. If I sketch in here a perpendicular to this line, I'm going to kind of sketch it from here. So this line meets my original at a 90-degree angle, right? Let's see if we can find a rise and a run for this graph using these 2 points that I just labeled in black. So what would you say is the rise between these 2 points? How many, if I go from the left point to the right point, or the bottom to the top, how many squares do I have to count? Right, so I have to count up 4. So I have to count up by 4, and then what would the run be that connects these two? So the run is the horizontal distance between these 2 points. So to get from this point horizontally to that point horizontally, I'm only moving to the right by 1. So here's another thing that we observe about this pair of perpendicular lines. Yes, it's true that the rise and the run of this line have the same sign as one another, right? They're both positive, whereas the rise and the run of this other line were opposite signs to one another. That's why its slope was negative. This slope's going to be positive. But notice something else. The rise of one of these lines is the same as the run of the other. And conversely, the run of one of them is related to the rise of the other. So not only do we need to have an opposite sign on my slope, what else happens to it? If slope is rise over run, what's my slope for this blue line going to be? So for my 2 perpendicular lines here, because the rise of one of them is related to the slope, is related to the run of the other. In addition to being opposite, what else has also happened to my fraction? It's been flipped upside down. Not only is it the opposite of the other slope, it's also the reciprocal of the other slope. So, coming back to our original, there are two things that we have to do in order to produce the slope of a line which is perpendicular to a line whose slope we already know. We need to change its sign from positive to negative or vice versa, and we also need to flip it upside down. We need to take its reciprocal. So if I wanted to know in this example, this is our original, my original line had a slope of negative 7/8. What would the slope of this perpendicular line to it be? 8/7, positive 8/7. Because we switched the sign to take it from negative to positive, and we also inverted the fraction to turn it into 8/7. So that's how we find the slope of a line which is perpendicular to a line whose slope we know.